Hello everyone. The title of this video is Add and Subtract Rational Expressions, right, or fractions with unlike denominators. So in this video I'm going to go over many examples. I believe I have 36 of them, in which we're given fractions, either two fractions or three fractions, and we'll be asked to add them or subtract them, and then of course at the end simplify your result. So hopefully you recall that in order to be able to add and subtract fractions, the denominators of those fractions need to be the same. They need to be like or common, not unlike. So we'll be given fractions with unlike denominators, and we'll have to transform them into equivalent fractions with the same denominator. All right. Now, all the examples I'm going to be doing in this video are taken from a free online textbook at openstacks.org, and that book is their Intermediate Algebra 2nd edition. I'm in section 7.2, titled Add and Subtract Rational Expressions, and I'll be working on the exercises under the heading Add and Subtract Rational Expressions with Unlike Denominators. So I'm working on exercises 107 all the way through 142. And it says 36 examples. Example 1 in the video will correspond to exercise 107. Example 2 will be 108, etc., right, all the way down to example 36 being exercise 142. All right, so again, you can watch them all, fine. But if you're scrolling through these exercises here and you'd like to see me work on a particular one, say you wanted to see exercise 140 here, well, if you count down, that would be example 34, and I'll have timestamps for each example in the description of the video. So you just go to the timestamp for exercise or example 34, click on that, and you'll see me work on this exercise here, exercise 140. And you can do that with any of these. Alright, and as I like to say in every video, or at least I like to try to remember to say this, when you see me bring up a new example, pause the video. Pause the video and try to do it yourself first. See if you can work it out on your own first. And then watch me do it. And compare your work with mine. And see where you could improve things, or if you got it right, got it wrong. Just gauge how much of the material you're grasping. Right? Because if you're just watching me do it and not doing anything for yourself, you're probably not going to learn much of anything. Alright, so let's get into it. So again, this first example is exercise 107 from that page I was just showing you. Alright, so we're asked here to add or subtract, depending on what operation is presented, and just hopefully you recall too that when you see subtraction, it's just adding the opposite. Alright, so subtraction is really also addition, but addition of the opposite. And after we're done adding and subtracting, then we must simplify our final fraction, our final result. Make sure that the numerator and denominator of our final result have no common factors. Okay, so notice, as it said in the title of the video, that we're looking at fractions here that have unlike denominators. Right. The first fraction has a denominator of 10 times x squared times y, and the other fraction, that we're adding to it has a denominator of 15 times x times y squared. A totally different denominator, totally different expression. Alright, so off to the side here, I'm going to put down the steps I'm going to be following for every single example. So when we're adding or subtracting fractions, or really just adding or subtracting any expressions. Right. So first, and this is going to kind of tie into our previous video. Again, I'm hoping you're following along, watching the videos I've been making, or if you're in the section 7.2 of the Intermediate Algebra 2nd Edition OpenStax text. Hoping you've seen that the steps listed for finding the least common denominator. That'll be the first thing I do. Find the least common denominator, also abbreviated LCD. Right, then the second part, after finding the least common denominator, I'm going to rewrite each fraction as an equivalent fraction. So this first fraction I'm going to write as a new fraction, but that has the same value. Right? It's the same. It's an equivalent fraction. And then same thing with the second fraction. Right? The second fraction I'm going to write as an equivalent fraction with the same denominator. And the denominator I want to write them both having is this LCD. So I'm going to rewrite each fraction as an equivalent fraction with the LCD, right, with the LCD as the denominators. And then after this second step, you should then have two fractions with like denominators, right, with the same denominator, both of them having the LCD as the denominator. Right. So then the final two steps here. Third step is then actually add or subtract. And don't forget the rules here. When you take a fraction, say a over c, and then add or subtract, right? I'll put plus or minus here because you could do either one. Another fraction, b over c, and you notice how these have the same denominator, right, of c. That common denominator, c, the common denominator is also the denominator of the sum, or the difference. It's just the numerators you combine. So if you're adding, it would be, the numerator would be a plus b. If you're subtracting, the numerator would be a minus b. Right? So hopefully, you remember this rule. Right? When you have it, this is only when, again, you can only add or subtract fractions when they have the same denominator, and that's the whole point of these first two steps, is to get them to have the same denominator. And then the last part, and again, this was covered in earlier videos, earlier parts of the chapter 7 in that OpenStax text. Simplify that final fraction. And to simplify a fraction, right, you factor the numerator, factor the denominator completely, and then cancel any common factors that the numerator and denominator have. So I'm assuming here, right, I'm going to be assuming a lot. I'm going to be assuming that you know how to factor polynomials completely. Difference of squares, sum of cubes, difference of cubes, quadratic trinomials, factoring by grouping, all the methods you could refresh your memory with in Chapter 6 of that Intermediate Algebra 2nd edition book if you wish. But I'm going to be assuming you know how to factor polynomials, and also that you've seen my previous video on finding the least common denominator, or you've read yourself how to find the least common denominator of the denominators of multiple fractions. Alright, so here are the 4 steps I'm going to be following for all the examples in this video. Alright, so this first example, we have, again, first step, I'm finding the LCD. Alright. And I'm only going to write out the step names, or write out some of the steps in this first example. After this, I'll do things a little more quickly, but I'll still write certain things out. Alright, so the denominators here are 10 x squared y and 15 xy squared. Alright, now there are a couple ways you can do this. Alright, again, in my previous video on finding the least common denominator, I explained one way. Here I'll explain both ways if you wish. You factor completely. 10, that's 2 times 5 times, and then x squared is x times x, and then y is another factor times y. Right? So there's that 10x squared y factored completely. Same thing with 15. Now 15 is 3 times 5, okay? And what you do to find the LCD is line up like factors, line up common factors. So I'll put the times 3 over here because there's no 3 up there, and then 5 here underneath this 5. Alright, so 3 times 5, that's 15, and I'm just lining up common factors, times x times, and then y squared, well, that's y, which I'll line up with one of the other y's, and then times y again. Alright, so I know it's a funky way of doing it, but I'm just listing the factors and lining up common factors and leaving spaces when there's nothing, when they don't have it in common. And then the LCD is I simply just write the factors that are in these columns down here. The LCD is 2 times 5 times x again times y times 3 times y. Just kind of writing the factors that appear in these columns down here. And that's 2 times 2. I'll write them in another order. I like numeric, all the numbers out front. 2, that's 2 times 3 times 5 times x, which is x squared, times y, which is y squared, or 30 x squared y squared. Alright. So that was one way of finding the LCD. You factor completely each of the denominators, lining up any common factors, and then you just kind of drop the factors that show up in those columns, and you'll have your LCD factors. Another way to do it would be to write out, this is again 2 times 5 times x squared times y, and this was 3 times 5 times xy squared. And then the LCD, you just write each factor that shows up. There's a 2 and a 3 and a 5, right? There's a 2, there's a 3, there's a 5, and don't repeat it. Just don't repeat stuff. 2, 3, 5, okay. There's x's, there's y's, so x and y to some power. And then the powers on all these, right, the exponents, are just the highest powers that you see in any factorization. So the highest power of 2 is 2 to the first in either one of these, right, this one or this one. The highest power of 3 is 3 to the first. The highest power of 5 is 5 to the first. the highest power of x in either of these is x squared, so I'm putting x squared in the LCD, and the highest power of y is y squared, so I'm putting y squared in the LCD. So I get the same thing however you look at it. If you want to do this lining up common factors deal and then dropping factors, or if you want to write things with powers and then just use the highest powers of the factors that show up, either way you get the same least common denominator. Alright, so that was step 1. Alright, find the LCD. Now, I personally, for all these examples, I'm going to leave the LCD in factored form. And the reason I'm doing that is because it'll make it easier to simplify at the very end. Alright, so I will leave the LCD factored until the end, right? Until the end. Okay. Now comes the part where I'm going to rewrite each of these fractions. Right, now I'll do it in a kind of a long way for this first example. Right? So now I'm going to rewrite the fractions. The first one, 7 over, and it'll be nice and easy to do this, rewriting the fractions as an equivalent fraction with the LCD as the denominator, if you factor the denominators right now. So remember, this is 2 times 5 times x squared times y. That's 10 x squared y, totally factored. And what I want to do, right, is write this fraction as an equivalent fraction with the LCD as the denominator instead. So again, hopefully you recall how to write an equivalent fraction. You multiply the numerator and denominator by the same expression. Right, that way you're not changing the value of the expression, you're multiplying by 1. Well, the denominator has a factor of 2 already, has a factor of 5 already, has x squared, great, and it has y, this has y squared. Alright, so now we just think about what's missing. Well, LCD has a factor of 3. This doesn't, so I need to multiply by 3 and 3. 3 in the numerator, 3 in the denominator. Also, though, there's a factor of y that's missing in this denominator. Because this, the LCD has y to the second. This has y to the first. So I need to also multiply by a factor of y in the numerator and denominator. Alright, so that gives me this fraction. Now, like I said, I'm gonna keep denominators factored, and I'm gonna multiply the numerators. Alright, I'm gonna leave the denominators factored and multiply the numerators. So 7 times 3y, that's 21y in the numerator, and then the LCD, right, in the denominator. Right, this is just going to make the LCD. So 2 times 3 times 5 times x squared times y squared. Right. So there's a fraction that's equivalent to the original fraction, right? So 7 divided by 10x squared y, that has the exact same values as this fraction, no matter what you replace x and y with, right? As long as x is not 0, and as long as y is not 0, right? You got to make sure you keep that in mind, right? Because if x were 0, you'd have a denominator of 0. If y were 0, you'd have another denominator, the denominator would be 0 again. And you've seen me do this in previous videos. Hopefully you've seen me, right, do this, if you've been following along. I like to list all the values that I can't plug in for the variables, right? Values that make the expression undefined or make me divide by 0. Okay. Alright, so now the second fraction, right, the one we're adding, we have 4 over, and then the 15xy squared, which was 3 times 5 times xy squared. And same deal. All right, I'm going to multiply the numerator and denominator of this fraction by the same expression so that the denominator becomes this LCD. Right? And that way the fractions will have the same denominator. Alright, so look at what factors are missing here. You know, they're missing a 2. Right, 2's not in there. Also an x, right? This has x to the first. The LCD has x squared. And that's it. So in order to get the denominator to be the LCD, I need to multiply it by 2x. And if I multiply the denominator by 2x, I have to also multiply the numerator by 2x. And then, as I said with the first one, I multiply out the numerators. 4 times 2x is 8x. And I'm going to leave the denominator factored. And again, the denominator, I'm just going to write it the same way I've been writing the LCD. The denominator should be the LCD. 2 times 3 times 5 times x squared times y squared. And once again, this original fraction here, 4 over 15xy squared, that should have the same exact values as this fraction for any choice of x and any choice of y, as long as x is not 0 and y is not 0. Because again, I don't want to have 0 in the denominator ever. Right? That's undefined, dividing by 0. Alright, so I'm going to rewrite these now. Alright, I'm going to write now we have both fractions written with the same denominator. So I'll go back to the original page here and say this, right? This sum I was originally given is the same as, we rewrote this first fraction as 21y over the LCD, right? 2 times 3 times 5 times x squared times y squared, plus, and we rewrote this second fraction as 8x over the LCD, 2 times 3 times 5 times x squared times y squared. Alright, now I have what I want in order to be able to add. Now the denominators are like, they are common, they're both the same denominator. Alright, and now that both denominators are the same, we can add the fractions. Alright, let's pull up and now I didn't leave a lot of room here, but now that the denominators are the same, right, we can add these fractions. So here comes step 3, right, the add or subtract part. So remember that the common denominator, that's the denominator of the sum. Again, I'm going to leave it factored for now. So there's the LCD written once again, 2 times 3 times 5 times x squared times y squared. And I'm just combining the numerators, right? 21y plus 8x. Right. There's the fraction, that's the sum of these two. Now, simplifying. Factor the numerator completely, factor the denominator completely, cancel any common factors, and then write the final simplified version. Well, the first, the numerator here, 21y, that's 3 times 7 times y, plus this is 2 cubed times y times x. These don't have any common factors, so that is already as factored as you get. And this is already factored, right? That's why I've been leaving it factored, so that way the final, when I go through the simplification step, it's already factored. But these have no common factors, right? The only factor up here is 21y plus 8x. All right, there's nothing else to break apart. And I'm not seeing a factor of 21y plus 8x down here. And be careful, don't do bad canceling, right? A lot of people will cancel, there's an x here and an x here, I'll cancel one of those. And there's a y here and a y there. This is a sum. this is a sum. You can only cancel parts of products. You can only cancel parts of multiplication. You can't cancel parts of terms, parts of sums or differences, right? So don't do the bad canceling. So that's going to stay the way it is, and then nothing cancels. So now that I'm done, now that this is already simplified, now I'll multiply numbers. Right? So the final result, 21y plus 8x over, and then 2 times 3 times 5 is 30. Right? So 30 x squared y squared. Well, that was the LCD. Right? And here we go. Right? So the value of this first sum, the sum we were originally given, should be the exact same value as this expression here, as long as x is not 0 and y is not 0. Right? Because again, if x were 0 or y were 0, we would be dividing by 0. But for any other values of x and y, these should be the same. Right? So let me test this out. Right? And I'll do this just for a couple examples on our way through this video. But to test, test it out, see if you believe it, start replacing x and y with some numbers. And the value of the original expression, right, which I'll put here, here's the original expression, should be the same as the value of the final expression, no matter what you plug in for x and y. Again, as long as you never divide by 0, right, as long as x and y aren't 0 here. All right, so how about if x and y were both 1? X were 1 and y were 1. Well, the first expression would be 7/10 plus 4/15, if x and y were both 1. And if you put these together, this would be 21/30 plus 8/30. That'd be 29/30. Right, times 3 over 3 times 2 over 2 to get a common denominator of 30. 21 plus 8 is 29. So the value of that is 29/30. Look at the final expression. If x were 1 and y were 1, this would be 21 plus 8 in the numerator, 29, and then 30 in the denominator. And these are equal, and they should be. The value of your first expression should be the same as the value of your last expression, as long as you're plugging in values for the variables that are allowed, right, that aren't 0 here. And I leave it to you to test other ones. Okay, go ahead and try it out. Replace x with 2 and y with -3, or x with 10 and y with a half, right, and whatever you want, and see that the value of the original expression is exactly the same as the value of this final expression. Right? And you should be doing that, every time, testing your answers. Okay. All right. So yeah, that was a long one, right? It took almost 28 minutes there. But, usually in these videos you may have noticed the first example is usually the longest, because that's the one where I write all the steps I'm doing or all the explanations. So let's see if we can get a little quicker. All right, so number 2. All right. I'm doing the same 4 steps. All right. So what I'm going to do from here on out, though, when I want to find the LCD, I'm just going to write the fractions the way they are, but factor the denominators, right? So we have 1 over this denominator, 12 times a cubed times b squared. 12 factors to 2 squared times 3, and then we have a cubed and b squared. Right? And then I'm going to leave a little space. I'm going to leave a little space so I can multiply by stuff, when we go through step 2 and rewrite the fractions so that they have the denominator of the LCD. Alright, so the next one, 5 over, and then the denominator here, 9 factors to 3 squared, times, then we have a squared b cubed. Alright, and now that the factors, So I'm factoring the denominators completely. I'll just say factor denominators. And then we can write what the LCD is pretty easily, right? Hopefully. So if you look at all these denominators, both of them, there's factors of 2, so 2 to some power is going to be in the LCD. 3's are showing up, so 3 to some power is going to be in the LCD. There's A's, so A to some power, and there are factors of B, so B to some power. And again, the powers on these in the LCD are just the highest powers you're seeing in those factorizations of the denominators. So the highest power of 2 in either of these is 2 squared, so 2 squared is going to be in the LCD. The highest power of 3 is 3 to the first, 3 to the second, so 3 to the second is going to be in the LCD. The highest power of A is A to the third, so A to the third is in the LCD. And the highest power on B is B to the third, right? So B to the third is in the LCD. So again, you can leave it factored like this, and then at the very end, you know, if you wanted to multiply this out, this is 4 times 9, this is 36 a cubed b cubed. All right, so there's the LCD. This is what I want to turn both denominators into. All right, so now comes the second step. I'm going to rewrite each of these fractions with this denominator, right, with the denominator of the LCD. All right, so the first fraction, again, I'm going to multiply by, the numerator and denominator by the same thing. And let's see, there's 2 squared here, 2 squared in the LCD, 3 to the first, this has 3 squared, so I need a 3. A cubed, b squared, b cubed, so I need a b as well. So I multiply the numerator and denominator by 3b. And then the second fraction, same deal, I'm going to multiply the numerator and denominator by something so that the denominator becomes the LCD. Right? Well, it's missing 2 squared. Right? So I need 2 squared, I need 4. So I'm going to multiply the numerator and denominator by 2 squared. You got 3 squared, you got a squared here, this is a cubed, so it's missing an a. So I multiply the numerator and denominator by a, and then they both have b cubed. Alright, so now I have what I want. Right? I'm rewriting both fractions. This is 3b in the numerator over the LCD, which I'm going to, again, write in factored form. 2 squared times 3 squared times a cubed times b cubed. Plus, then the second fraction, multiplying the top by, now 5 times 2 squared, that's 20. Right, so 20a over, and then the LCD, right? It should be 2 squared, there's 2 squared, there's 3 squared, and then there's a squared times a, so a cubed, and then there's b cubed, right? And now they have the same denominator. Right, now they have the same denominator, which is what I want, right? And now that they have the same denominator, I can put it together. We can add them. The LCD will be the denominator of the sum, 2 squared times 3 squared times a cubed times b cubed. And then I'm just combining the numerators. The first numerator plus the second numerator. All right. And then we try simplifying. Well, the numerator doesn't factor any further. 3b plus 20a, there's no common factor to pull out. So that's its own factor, and I'm not seeing a factor of 3b plus 20a down here, right? So nothing cancels. This is it. So we have, now if you like the a's first, you could put 20a plus 3b, but 3b plus 20a or 20a plus 3b in the numerator. And then actually I like to then, now that everything's canceled, I like to simplify numerical coefficients, as I did earlier, 4 times 9 here. We have 36 a cubed b cubed in the denominator. Alright, and there's your final result. So again, this original sum I was given, this should have the same value as this expression at the end. For any value of a and b, as long as you don't plug in values of a and b that make you divide by 0. Well, those values would just be 0 and 0, right? If a were 0, that would be bad, so a can't be 0. Same thing with b, right? If b were 0, you'd have a denominator of 0. So as long as a is not 0 and b is not 0, this will work. The value of the original expression should be equal to the value of this final one. And again, I leave it to you. I'll leave this one to you. Replace a and b with any numbers except for 0, and check, is the value of the first expression equal to the value of this final one? And they should be. Alright, so these examples had, two variables in them, x and y, but the procedure doesn't change no matter what you're looking at, right? If it has one variable, two variables, three variables, the procedure doesn't change when you're adding or subtracting. Alright, so number 3, example 3. 3 over r plus 4 plus 2 over r minus 5. These denominators are already as factored as they're going to get. So I can tell you the LCD right now. It's just going to be, there's a factor of r plus 4 to the first power, right? There's r plus 4 to the first, no r plus 4 in this other denominator, times, and there's a factor of r minus 5 showing up in the denominators, so r minus 5 will be a factor of the LCD, and it's r minus 5 to the first, because again, the highest power on r minus 5 in either of these denominators is r minus 5 to the first. So this, and if you want to multiply it out, right, this would be r squared minus r minus 20, but this is the LCD, right, and this is what I would like to transform each fraction into, right? Each fraction's denominator into. Right? I want both denominators to be this. Alright, so as I did in the last example, we have 3 over, r plus 4. I'm going to leave some space, plus, so we can write what we're multiplying by to change the denominator. And then 2 over r minus 5. Alright, and then this first fraction, there's a factor of r plus 4 in the denominator, so I'm only missing r minus 5, right? So I need to multiply by r. Don't forget to put parentheses around this stuff, right? I'm multiplying by the entire factor, the entire quantity, r minus 5, and the same in the numerator, right? So I'm multiplying the 3 times the quantity, r minus 5. And then this second fraction, 2 over r minus 5 has, r minus 5 is a factor in the denominator. So the only factor it's missing is the r plus 4. So I multiply by r plus 4 in the denominator and the numerator. Again, don't forget your parentheses around these factors. Alright, well then, multiplying the numerators, we're going to be distributing a lot. 3 times this factor of r minus 5, that'd be 3r minus 15 over the LCD. Right? Again, I'm going to leave the LCD factored. R plus 4 times r minus 5. Plus this second fraction, again I'm going to rewrite it, multiplying the 2 by r plus 4, give me 2r plus 8. Over the LCD, and again you can write it, I'm going to write them in the same order, these factors, because it doesn't matter what order you put the factors in, you get the same product, right? So r plus 4 times r minus 5. Just so you can tell that, hey, these denominators are both the same now. Right, and now that the denominators are both this LCD, the denominators are the same, we can add. Right? And when you add two fractions with the same denominator, right, that denominator is the denominator of the sum. So we have r plus 4 times r minus 5 in the denominator. And then you're adding these numerators. I'm taking this numerator, 3r minus 15 plus this numerator, and just combining like terms. So 3r plus 2r, that's 5r, negative 15 plus 8 would be negative 7. And then try simplifying, right? So here's the sum. All right, I've got a single fraction now. And then see if you can simplify. Well, 5r minus 7 doesn't factor anymore. There's no way to factor that any further. So 5r minus 7 is its own factor in the numerator. And I am not seeing a 5r minus 7 factor in the denominator. So this is as simple as it gets. Now you can leave everything factored if you wish. There's nothing wrong with this. Or, if you wanted to multiply everything out, the numerator has a factor of 5r minus 7. And the denominator, when you multiply it out, as I did up here, would be r plus 4 times r minus 5 would be r squared minus r minus 20. All right, and this is totally valid as well. All right. And then as I do, right, and as I've done in previous videos, and I'm going to do in every single example, I would also like to list the values I can't replace r with. So looking throughout this whole process, just pick what are the values of r that would make any denominator, right? Any denominator equal 0. Well, if r were negative 4, that would be bad, right? Because the first denominator would be 0. Or, if r were 5, right, that would make this other denominator 0. And those are the only factors that show up in the denominators, r plus 4 and r minus 5. So the value I replace r with can't be negative 4 or 5. It can be anything else, though. And then, test it out. Again, I'll leave this to you. I think I'll just do it for that first example. But replace r with any number you want, right, except negative 4 or 5, and see if the value of the original expression is the same as the value of this last expression, right, this factored form or this one. And they should be. Right? The original and the final should have the same value no matter what you plug in for the variable. Right? Again, as long as you're not dividing by 0, ever. All right, so example 4. Pretty similar. So I'm hoping you can see that the LCD, which the denominators are already as factored as they can be. S minus 7, S plus 3. So just S minus 7 times S plus 3 is the LCD. Right? So this is what I want. That would be S squared minus 4S minus 21 if you multiplied it out, but I'm going to leave it factored. This is what I want to be the denominator of both of these. All right. So the first fraction, 4 over S minus 7, right, what I'm going to multiply the denominator and numerator by is the factor S plus 3. All right, that's the factor that's missing. All right, so now the denominator will be the LCD. And the second fraction, 5 over S plus 3. All right, and again, this is its own factor, S plus 3. So it has a factor of S plus 3. It's missing the factor of S minus 7. So I multiply the numerator and denominator of this fraction by the quantity S minus 7. All right, and in doing so, this first fraction becomes the following. The numerator would be 4s plus 12, right, distributing the 4 there, over the LCD, right, s minus 7 times s plus 3, plus, and then multiplying these two, 5 times the quantity s minus 7, that'd be 5s minus 35 over the LCD, s minus 7 times s plus 3, or s plus 3 times s minus 7, doesn't matter. But they're the same denominator now. They have the same factors. And so when I add them, that common denominator, right, is the denominator of the sum. So s minus 7 times s plus 3. And when you combine the numerators, right, you're just taking the whole first numerator plus the whole second numerator and just combining like terms. 4s plus 5s would be 9s, and then 12 plus negative 35 would be negative 23. And then you try simplifying this. So here we have a single fraction, right? This is the sum of the two fractions we were given. And then you try simplifying. Well, as in the previous example, the numerator can't factor any further. So the only factor in the numerator is 9s minus 23. And I'm not seeing 9s minus 23 as a factor in the denominator, so this is as simple as it gets. And you can leave it in factored form like this, or write 9s minus 23 in the numerator, and actually multiply out the denominator there. That would again be s squared minus 4s minus 21. And this is also totally valid, right? Totally fine. So the value of the original sum will be equal to this value here, right? The value of this expression, for any value of s except for, right, s cannot be positive 7 or negative 3. Right, because if I use positive 7 for s or negative 3 for s, we'll have denominators of 0 throughout this problem, and that's bad. Right? You can't divide by 0. That's undefined. All right, and I leave it to you to check, test out different values of s and see if the original expression has the same value as the final expression, and they should. Okay, so moving right along, example 5, very, very similar. All right, so again, I'm going to start speeding things up a little bit. The denominators are factored already. So the LCD is just the product of those two. Right? It would just be 3w minus 2 multiplied by w plus 1. And I'm not going to write the multiplied out version yet. Right, we'll just leave that as the LCD. Okay. And then what we're going to do is I'm going to put them together right now, because we're going to get this as the LCD. Right? That LCD, we're going to get that as the denominator of both these fractions. So that's going to be the denominator of the sum. So I'll have 3w minus 2 times w plus 1 as the denominator of the sum, this LCD, right? And then in the numerator, I'm going to write what would I do to the first numerator plus what would I do to the second numerator. So if you recall, for this first fraction, to get the LCD in the denominator, I have to multiply the numerator and denominator by w plus 1. So the numerator there, I would have 5 times w plus 1. Okay, that's the first numerator. Plus, and then for the second numerator, to get this denominator be the LCD, I'd have to multiply the numerator and denominator by 3w minus 2. So 3w minus 2 in the denominator, 3w minus 2 in the numerator. So the second numerator would be 2 times the quantity 3w minus 2. Alright, so I'm going to kind of skip ahead of this. Alright, then simplifying, we have 5w, I'll write this out, 5w plus 5 plus 6w minus 4. So we have 5w plus 6w, that's 11w. And we have a positive 5, right, after distributing, and then a negative 4. Right? Positive 5 plus negative 4, that'd be positive 1. Right, so the numerator is just 11w plus 1. And the denominator is still this LCD 3w minus 2 times w plus 1. And then, there's a single fraction. That is the sum of these two. and the numerator doesn't factor any further, so and I don't see a factor of 11w plus 1 in the denominator, so this is as simple as it gets. Right? Or you could also multiply out the denominator if you wish. Right? The numerator is 11w plus 1, and the denominator would be 3w, after foiling here, 3w squared, then plus 3w minus 2w, so plus 1w, and then minus 2. Okay, this is also valid right here. And test it out. Alright, you can replace w with any number you want, right, except for 2/3 and -1. Alright, w can't be 2/3 or -1, because those will make me divide by 0. Those will give me denominators of 0, and that's bad. Right, that's undefined. But I leave it to you to check. Replace w with any number you want, except 2/3 or -1, and see that the value of the original expression is the same as the value of the final expression. And it should be. Okay. So again, example 6, same deal. Both denominators are already completely factored. So I should be able to state the LCD, the least common denominator, right now. And they're different factors to the first power. So those are just going to be the factors of the LCD. The LCD is going to be 2x plus 5 times x minus 1. Right, and this is what I'm going to transform both these into. Right, I'm going to write both of these as a fraction with this denominator. So again, I'm going to kind of skip over a step here, and I'm hoping you watch the first 4 examples. Right, the first 4 examples go into more detail. But we'll have 2x plus 5 times x minus 1 as the denominator of both of these. So that's going to be the denominator of their sum. And then for this first fraction, right, in order to get the LCD in the denominator, I would multiply the numerator and denominator by x minus 1. So the first numerator would be 4 times the quantity x minus 1 plus, right, then I add the second numerator, which would be 2 times the quantity 2x plus 5. Right, because in order to write an equivalent fraction with this LCD as the denominator, right, I would have to multiply the numerator and denominator of this fraction by 2x plus 5. Alright, then distributing the 4, distributing the 2, and combining like terms, we have 4x plus another 4x, right, 2 times 2x, so that's 8x. For the constants, you have -4 plus 10, 2 times 5. -4 plus 10 be plus 6. Right. And then, denominator is the LCD here, 2x plus 5 times x minus 1. Now the numerator could factor a little further, right? 8x plus 6, they have a common factor of 2. I can pull a 2 out. So there's a factor of 2, and then another factor of 4x plus 3 over 2x plus 5 times x minus 1. But I'm not seeing any common factors in the numerator and denominator. So you could leave it like this if you want, or leave it in factored form, or actually multiply things out. The numerator again would be 8x plus 6, and the denominator would be 2x squared minus 2x plus 5x, so plus 3x, and then minus 5. And this is also equally valid. All right. And again, test it out. Go back to the original sum here for example 6 and replace x with any number you want except -5/2 or +1. Right, x can't be -5/2 or +1, because if x were any of those numbers, you'd be dividing by 0. You'd have denominators of 0. But for any other value of x, the value of this original sum should be equal to the value of the final expression. And I leave that to you to test some values out. Okay, so again, a lot of these examples here, examples 5 through 8, are very similar, where each denominator is already completely factored. So you should be able to state the LCD. All right, so for example 7, right, again, both denominators are totally factored already. So the LCD should be quite simple to state. It would just be y plus 3 times y minus 1. All right. So that's going to be the denominator of both fractions. All right, so when I add them together, it's going to be the denominator of the sum. All right, so the LCD will be the denominator of the sum, y plus 3 times, y minus 1. That should be minus, y minus 1. And the numerator of the sum is, the sum of the numerators. The first numerator would be 2y times the quantity y minus 1. Right, because I would have to multiply the first fraction by y minus 1 over y minus 1 to get the LCD in the denominator. Plus the second fraction, I'd have to multiply by y plus 3 over y plus 3 to get the LCD in the denominator. So the numerator that we're adding here is 3 times the quantity y plus 3. Alright, and then we'll be distributing the 2y, right, multiplying these, distributing the 3. This would be 2y squared. And then we have minus 2y plus 3y plus 1y. And then plus 9. Right, after multiplying and combining like terms. So you see it, hopefully 2y squared minus 2y plus 3y, we're making the positive 1y, and then 3 times 3 for the plus 9. And the denominator is the LCD, right? Y plus 3 times y minus 1. And I believe this is as simple as it gets. Yes, this is a quadratic in the numerator, 2y squared plus 1y plus 9. But when you try do the b squared minus 4ac, right? 1 minus 4 times 2 times 9, that's a negative number. This is not factorable. Right? It's not a perfect square. Or you could try the AC method, 2 times 9 is 18, and then try to think of factors of 18 that add up to positive 1, and there aren't any. So that factors as, that's the only factor in the numerator. Right, I'll put parentheses around it if you want, you don't have to, but that's the only factor in the numerator. And I am not seeing a factor of 2y squared plus y plus 9 in the denominator. So there's nothing canceling here. This is as simple as that fraction gets. Now again, you could also multiply everything out. Say this is 2y squared plus y plus 9 in the numerator, and then multiply write the LCD as a fully formed polynomial. We'd have y squared plus 2y minus 3 in the denominator, and again, totally valid. Right? This is equally valid. And the values that y cannot be replaced with. And again, I like to write this at some point during the problems. The values that y cannot be replaced with throughout this is negative 3 or positive 1. Right? Because if you replace y with either of those two, you'll have denominators of 0 throughout, and you can't have a denominator of 0, right? You can't divide by 0, that's undefined. And I leave it to you to check. Right? Replace y with numbers other than negative 3 or 1, and see that the value of the first sum is equal to this value of this last expression, right, either in factored form or not. Alright, example 8, pretty similar. We have two fractions here where denominators are already factored completely, so we should be able to state the LCD pretty easily. Right? The LCD would be z minus 2 times z plus 5. And this is going to be the denominator that I end up with for both fractions, right? I want to change both of these fractions into an equivalent fraction that has this denominator. So that's going to be the denominator of the sum. Right, so I'll just skip ahead to the sum, like I've been doing for the previous couple of examples. So the denominator of the sum is the LCD, and then the numerator of the sum is the sum of these numerators after I get them to have the LCD as the denominator, right? The first one, I'd have to multiply the top and bottom by z plus 5. So the first numerator would be 3z times the quantity z plus 5. Right, and then that numerator gets added to this numerator, which would be 1 times z minus 2, or just z minus 2. Because to make the denominator the LCD here, I'd have to multiply the numerator and denominator by z minus 2. Okay. All right, then we're multiplying these three, distributing the 3z. Distributing the 1. Really no need to write the 1 there. And combining like terms, we have 3z squared plus 15z, right? 3z times 5. Plus 1z, so that'd be plus 16z. Right, 15z plus 1z. And then minus 2. Minus 2. Divided by the LCD, which again I'm writing in factored form right now. Z minus 2 times z plus 5. Alright, and then we try, you can try factoring that quadratic in the numerator, but if you did the b squared, 16 squared minus 4ac, so minus 4 times 3 times negative 2, that is 280, which is not a perfect square. So this is not factorable. Again, if you wanted to try the AC method, 3 times negative 2 is negative 6, and then you would try to find pairs of factors of negative 6 that add up to 16, and you couldn't do that. Right, so this is not factorable. That's its own factor. And I'm not seeing that 3z squared plus 16z minus 2. I'm not seeing that factor in the denominator. So that's it. Right, this is as simple as it gets. No common factors in the numerator and denominator. And once again, if you want, you could write it out where you multiply things out. The numerator would be 3z squared plus 16z minus 2. And the denominator at the LCD would be z squared plus 3z minus 10. Totally valid answer. Same as the other one. And the values you can't replace z with here are 2 and negative 5. Right? Because those will make you divide by 0. Those will give me denominators of 0 throughout the problem. So as long as z is not 2 or negative 5, the value of this original sum should be the same as the value of either this box here or this box, whatever one of these final expressions was. And I leave it to you to test out different values of z if you wish. Alright. So now in example 9, we're going to start having to factor our polynomials in the denominator now. Alright, we'll start. Now we're back to some examples with 2 variables. Alright, so first thing I'm going to do, now I notice the denominators are not completely factored. So I'm going to factor them. Alright, so the first fraction is 5b over, then this a squared b minus 2a squared. Those have a common factor of a squared, right? So I pull a squared out, and then what's left over is b minus 2. Okay, there's the first denominator totally factored. I'll leave a little space, and we go plus, and then the second fraction has a numerator of 2b, and its denominator is b squared minus 4, which is a difference of squares, right? That would factor to b minus 2 times b plus 2. Alright, and now that I have factored the denominators completely, I can very easily state the LCD. Right? So factors of a show up, so you're going to have a to some power in the LCD. There's factors of b minus 2 showing up, so I'll have b minus 2 to some power in the LCD, and b plus 2. Alright. Now the highest power on a is a squared, so that's going to be in the LCD a squared. And then b minus 2's highest power is b minus 2 to the first, so we have first power there, and the highest power on b plus 2 is also to the first, right? So here's the LCD. So once again, I'm going to change each fraction. I'm going to rewrite each fraction so that this is the denominator of both fractions. So the only factor missing in the first denominator is b plus 2. Right? So I need to multiply the numerator and denominator of this by the quantity b plus 2. And for the second fraction, they're missing a squared. Right? The denominator is missing a squared. Right. So now both fractions have the same denominator. So I'm just going to put them together now. Right. So the denominator is common. It's this LCD. That's going to be the denominator of the sum, a squared times b minus 2 times b plus 2. And the numerators are these. Right. The first numerator is 5b squared plus 10b. This is the first numerator, plus the second numerator is 2a squared b. Okay. And really, there's nothing common up top. There's no like terms. You know, this first numerator plus this second one. No common terms, no like terms. There is a common factor, though. Each one of them has b in common. So I could factor a b out. And when I remove b, you have 5b plus 10 plus 2a squared left over in the numerator. And the denominator is already completely factored. A squared times b minus 2 times b plus 2. And looking at the numerator, right, there are factors of b and 5b plus 10 plus 2a squared. Well, I'm not seeing any factors of b in the denominator. Not seeing any factors of 5b plus 10 plus 2a squared in the denominator. So this is as simple as that fraction gets. All right, and again, you can leave it factored, or you can multiply things out. I'm going to stop doing that from here on out. But you can leave it factored form like this: numerator factored, denominator factored, and there are no common factors in the numerator and denominator. Or you can actually multiply it all out and write the multiplied out numerator, the multiplied out denominator, and it's the same thing. Alright, so the value of this sum that we started with, right, should be the same value as this fraction here, no matter what I plug in for a and b. As long as a is not 0, right, because that would make me divide by 0 there. And as long as b is not 2 or negative 2, because I'll make these two factors 0 in the denominator, and I don't want to divide by 0, right, ever. And if a were 0, that'd make this denominator 0. If b were 2 or negative 2, that would make these denominators, it would give you at least one denominator of 0 throughout the problem, and that's not good. You can't divide by 0, it's undefined. Alright, and once again I'll say, I'll leave it to you. Plug in different values of a and b, and see if the original expression has the same value as this last one. Okay, example 10, pretty similar. So I notice that the denominators are not factored completely yet. So I'm going to start off by factoring the denominators, and then we'll state the LCD. So first fraction, 4 over, then CD plus 3C, they have a common factor of C, so I pull C out, and you'll be left with D plus 3. Leave a little space there, and then plus 1 over, and then D squared minus 9 factors to D minus 3 times D plus 3. All right. So now that the denominators are completely factored, alright, the LCD should be pretty quick to state. There will be C to the first times, and then D plus 3 to the first, and then times, and then there's a D minus 3 to the first as well, right? And that's the high. And those are all of them. The highest power on any of those factors is the first power. So there's the least common denominator. That is what I'm going to transform both of these denominators into. Now for the first fraction, to do that, I'd have to multiply the denominator and the numerator by D minus 3, the quantity D minus 3. Here, to do that, I'd have to multiply the numerator and denominator by C. Right. So now both fractions have this LCD as a denominator. Then I can add them, right? And when they have the same denominator, that denominator will be the denominator of the sum. C times D minus 3 times D plus 3. There's the denominator of the sum, or D plus 3, D minus 3, whatever order you put them in is fine. And then the numerator of the sum is the combination of these numerators. So what I'm doing here is I'm multiplying 4 by D minus 3. So that's 4D minus 12 plus 1 times C, right, plus C. And there we go. And try simplifying. 4D minus 12 plus C, that doesn't factor any further. So this is as simple as it gets. There's no 4D minus 12 plus C factor in the denominator. So that's as simple as it gets. Again, you can leave it this way if you wish in factored form, or actually multiply everything out and write the multiplied out numerator, multiplied out denominator. But as I said in example 9, from here on out, I'm just gonna leave the numerator and denominator factored with no common factors in the numerator and denominator at the end. All right, and again, the value of C, can't be 0, because that'll give me a denominator of 0. And the value of D can't be 3 or negative 3. All right, but anything else is fine. All right, any other choices for C or D are fine. And I leave it to you. Replace C and D with any values besides these, and see if the value of the original expression is the same as the value of my final expression. Right? And it should be if you did everything correctly. Alright, so those were a couple examples with multiple variables. Now we're getting back into the examples with a single variable. But the procedure doesn't change. Alright, the procedure does not change. So first I factor each denominator completely. So first fraction, we have negative 3m in the numerator, and 3m minus 3 factors to 3 times m minus 1. Now you could cancel this factor of 3 in this first fraction here, but I'd say save it. Alright, we'll wait till the end to do some canceling. Plus, oops, I should have left a little more space, whatever. Alright, plus second fraction, you got 5m in the numerator. The denominator factors to m plus 4 times m minus 1. Alright, so the LCD is 3 to the first, the highest power of 3 is 1, m minus 1 times m minus 1 to the first, and then times m plus 4, that's another factor that's showing up to the first. Right, so there's the LCD. Alright, so that's going to be the denominator of the sum. So I'll just do that right now. I'll be writing both of these fractions so that they have this is the denominator, 3 times m minus 1 times m plus 4. And in this first fraction, right, I'll be multiplying the numerator and denominator by m plus 4. Right, I'd have to multiply the numerator and denominator by m plus 4 to get this LCD as the denominator. And then this second fraction, I'll have to multiply the numerator and denominator by 3. Right, so times 3 times 3. Right? Times 3, not negative 3. Right? Alright, so LCD in both denominators, I put them together with the LCD as the denominator of the sum. Then this first numerator, when I multiply, would be negative 3m squared minus 12m, and then plus, and then the other numerator is 15m. Alright, then I combine like terms up here. We'd have negative 3m squared plus 3m. Right, plus 3m. Negative 12m plus 15m. Right, and then divided by, and then 3 times m minus 1 times m plus 4. Okay. So now I have a single fraction. Wonderful. Right, this is the sum of those two fractions I started with. But, we're trying to simplify. So I factor the numerator, factor the denominator, and see if there are any common factors. Now this time, the numerator can factor. And you may have seen this before, but remember when the lead coefficient of a polynomial is negative, a good tendency to have is to factor out the opposite of the greatest common factor. Factor out a negative. So the numerator here, the greatest common factor is 3m. For both these terms, 3m. But because the lead is negative, I'm going to pull out negative 3m. And if I do that, I'll be left with m minus 1. And then the denominator is still totally factored, the LCD, right? I mentioned that way earlier in the video that I'm just going to keep the denominator totally factored throughout. All right. And now look, finally. This is the first example we've come across in this video where the numerator and denominator had common factors. There's a factor of 3 in the numerator and denominator, so I'll cross those out, leaving me with negative 1 in the numerator. Okay. Then there's no factor of m in both, but there is this factor of m minus 1. Right? M minus 1 is common. I remember when you cancel common factors, technically they become 1. Alright, but I'm not going to write that. So what I'm finally left with, in the numerator I have negative 1 times m, so negative m, right, the opposite of m. Divided by, and what I'm left with in the denominator is m plus 4. Now you could also write this way. Remember, when there's a factor of negative 1 in the numerator or a factor of negative 1 in the denominator, you could pull a minus sign out in front of the fraction. Pull the minus sign out front, and it's the opposite of the fraction, m divided by m plus 4. Right, just putting that minus sign in line with the middle there. So this is fine. This is totally fine as well. All right. As long as m is not 1 or negative 4, right? Because if m were 1 or negative 4, you'd have a denominator of 0 throughout this problem, right? And you don't want to have denominators of 0 ever. Okay. And again, test it out. Replace m with any number that's not 1 or negative 4. Here in this original expression and in this final one, and they should give you the same value. All right. Next example, same stuff. Same stuff. First, I'm going to factor each denominator completely. So 8 in the numerator, and then 4n plus 4, they have a common factor of 4. I'll pull 4 out, but 4 factors even further. Right? 4 factors to 2 squared. So that's 2 squared times n plus 1. Right? 4 times n plus 1 for that first denominator. Plus, again, I should have left some more space there, sorry. Second fraction, 6 over 6 divided by. That denominator would factor to n minus 2 times n plus 1. And now that both denominators are factored completely, we can very easily state the least common denominator. So we have a factor of 2 showing up, and the highest power is 2 squared, so 2 squared is going to be a factor of the LCD. n plus 1 to the first is the highest power of n plus 1. n minus 2 to the first is the highest power of n minus 2. So here's our LCD. 4, or 2 squared, times n plus 1 times n minus 2. Alright, so in order to transform each fraction into a fraction, an equivalent fraction, with this denominator, right, with the LCD as a denominator, the first fraction I'd have to multiply the numerator and denominator by the quantity n minus 2. Alright, now the denominator is the LCD. The second fraction, I'd have to multiply the numerator and denominator by 4. Alright, or by 2 squared, which I'll write as 4. But okay, so now that the denominators are the same, right? That's going to be the denominator of the sum. Right, so, and then we just combine the numerators. First numerator is 8n minus 16, right? 8 times n minus 2, plus the second numerator is 24, right? 6 times 4, 6 times 2 squared. And we can simplify this, right? That's 8n plus 8. That's 8n plus 8 in the numerator after combining like terms. And we still have the LCD in the denominator, 2 squared, or 4 times n plus 1 times n minus 2. The numerator can factor further. Now I'm going to start simplifying, right? Now I have a single fraction, great. That is the sum of these two fractions in the beginning, but it's not simplified, right? I can pull an 8 out, right? 8 is a common factor of the numerator. Now 8 is 2 cubed, right? So I'll pull 2 cubed out, which is 8. And once I do that, I'll have n plus 1 left over, divided by, and then you have the LCD in the bottom, 2 squared times n plus 1 times n minus 2. And I'm seeing some common factors. Right? I am seeing common factors in the numerator and denominator. And those common factors are, right, well, there's 2 2's in the denominator. There are 3 2's in the numerator, 2 cubed. So 2 of those will go away, leaving me with 2 of the first. So just 2 left over in the numerator. I'm also seeing a common factor of n plus 1, right, in the numerator and denominator. So those will cancel. All right, so what I'm left with is 2 in the numerator. That's it. And n minus 2 in the denominator. And since it's the only factor left in the denominator, there's no need for parentheses around it. And here we go. The value of this expression will be the same as the value of the original expression for any value of n you want except 2 and negative 1. I can't replace n with 2 because that'll give me denominators of 0. And looking throughout the problem here, I'm also seeing the factor of n plus 1 show up in the denominator, so n can't be negative 1 either, because that'll make me divide by 0 somewhere. But for any other value of n, the value of the original expression should be the same as the value of this expression here. And test it out. If I were to replace n with 3, the value of this expression and the original should be 2, should be equal to 2. Alright, if n were 4, the value of this expression would be 1, and so should this. And again, test it out. I leave it to you to test it out for different values of n, as long as those values aren't 2 or negative 1. Okay. Example 13. Right, every example is the same. It really is. Right? Just the same 4 steps where I find the LCD, right, by factoring the denominators first, then rewriting the fractions so they have the same denominator, right? So they have that LCD as a denominator. Putting them together, right, adding or subtracting the fractions once they have the same denominator, and then simplifying. Right? It's the same 4 steps every single time. So here, first fraction, we have 3r over that denominator factors to r plus 6 times r plus 1 plus, and then second fraction, 9 over, and that denominator factors to r plus 3 times r plus 1. Now that the denominators are totally factored, we can state the LCD very quickly. R plus 6 to the first times r plus 1 to the first times r plus 3 to the first. Right, there's your LCD. So if I was to make both of these fractions have this denominator, the first fraction, I have to multiply the numerator and denominator by r plus 3. Right, the quantity r plus 3. That gives me the same factors, the LCD. And the second fraction, I'd have to multiply the numerator and denominator by r plus 6, right, the factor of the quantity r plus 6. Okay, but don't forget you got to do it to both the numerator and the denominator. Alright, so now that both fractions have the same denominator, right, this LCD as the denominator, I can put them together. And that common denominator will be the denominator of the sum. So the LCD, r plus 6 times r plus 1 times r plus 3, that's going to be the denominator of the sum. Now the numerator of the sum will just be the combination of these two numerators here. Now the first numerator is 3r times r plus 3. That'd be 3r squared plus 9r. Alright, there's the first numerator. Plus the second numerator, 9r plus 54. 9 times r plus 6, right? 9r plus 54. And then I combine some like terms up there. That would be 3r squared plus 18r plus 54 divided by the LCD, right? R plus 6 times r plus 1 times r plus 3. So there's the sum of these two fractions. Cool. But it's not simplified, right? After I add or subtract, then I'm going to simplify. Factor the numerator, factor the denominator, and cancel any common factors. Alright, well the first, the numerator, there's a common factor of 3. And if I were to pull 3 out, what would be left would be r squared plus 6r plus 18. It would be r squared plus 6r plus 18. Alright, because I'm going to check by redistributing. And then r squared plus 6r plus 18, that wouldn't factor any further. You could do the b squared minus 4ac and see that you get 36 minus 72. That'd be negative, so this is not factorable. Or if you tried the AC method, said 18 is 1 times 18 is 18, and you try to find a pair of factors of 18 that add to positive 6, that's not happening either. Alright, so that's as factored as the numerator is going to get, and the denominator I've already kept as factored as it's going to get, right? The LCD r plus 6 times r plus 1 times r plus 3. And since everything's factored and I'm not seeing any common factors in the numerator and denominator, this is as simplified as that gets. Okay. Wonderful. All right, and again, this value, the value of this expression should be the same as the value of the sum that we started with for any value of r except -6, -1, and -3. Alright, because if I replace r with any of these three values, you're going to see a denominator of 0 show up throughout the problem, and you can't have denominators that are 0. Alright, example 14 is very, very similar, right? And I'm doing the same steps every single time. So we have first fraction 2s over, this denominator factors to s plus 4 times s minus 2 plus then 4 over this denominator would factor to s plus 5 times s minus 2. Alright, now that the denominators are totally factored, we can easily state the LCD. Alright, and the LCD would be s plus 4 times s minus 2 times s plus 5. Right, leaving it in factored form. Alright, so this first fraction, I'd have to multiply the numerator and denominator by s plus 5 to get the denominator to be the LCD. Second fraction, I'd have to multiply the numerator and denominator by s plus 4 to get the denominator to be the LCD. And now both denominators are the same. We can add the fractions together, right? And the denominator, that LCD, will be the denominator of the final sum here, s plus 4 times s minus 2 times s plus 5. And the numerators. The first numerator is 2s squared plus 10s, alright, 2s squared plus 10s plus 4s. So we have 10s plus 4s be plus 14s, and then plus 16. Right. So I'm just kind of combining like terms right there. Okay, then great, we have a single fraction. That is the sum of our first two fractions. Now let's see if we can simplify. Now I notice in the numerator all three terms have a common factor of 2. And if I pull that out, I get s squared plus 7s plus 8. S squared plus 7s plus 8. And let's see, is that factorable? Are there factors of 8 that add up to 7? No, 1 and 8, 2 and 4. And neither pair add up to 7. So that's as factored as the numerator gets, and the denominator is already nice and factored. Right? And I am not seeing any common factors in the numerator or denominator, so this is it. And again, you can leave it factored like this, or actually multiply out the numerator, multiply out the denominator if you want. Alright, and the values of s that can't be used are -4, +2, and -5, right? Because these values of s will give me denominators of 0 throughout this problem. And I leave it to you to check, replace s with some other numbers besides these and see if the original expression is the same value as the final expression, and it should be. Okay. Now we're still doing the same procedure, only this time a little easier for these next few examples. Example 15. See how the denominators are already factored, so I can tell you the LCD right now is going to be t minus 6 times t plus 6. And that's going to be that's going to be the denominator of the difference. Now we're subtracting too, right? This is the first example where we have a minus. So I got t minus 6 times t plus 6, right? The LCD is going to be the denominator of the difference. And then the numerator will just be the difference in these numerators. The first numerator would have to be t times t plus 6. Then we do minus, and then again this entire numerator, right? So don't forget parentheses around it, right? That people tend to forget that with subtraction. You're not just subtracting the first term of the next numerator, you're subtracting the whole thing. And I'd be minus t minus 2 times t minus 6. Because in order to get the second fraction to have a denominator of the LCD, I'd have to multiply the numerator and denominator by t minus 6. All right. So this first numerator, right, is t squared plus 6t. Right, that's the first numerator. Minus the second numerator. When I do t minus 2 times t minus 6, that'd be t squared minus 8t plus 12. And again, I'm subtracting all of that. We're taking the first numerator, whatever it is, and subtracting every term of the second numerator. So that's why I'm again putting the second numerator in parentheses, divided by the LCD here, t minus 6 times t plus 6. All right, so we're distributing this negative, right? We're subtracting every term of that second numerator. So what I have now is, t squared minus t squared. That's gone. 6t minus negative 8t. That'd be 6t plus 8t. So 14t. And then minus 12. All right, divided by, and then t minus 6 times t plus 6. All right. So now I have a single fraction, right? Single fraction, the numerator is simplified. Now I need to simplify the fraction. Try factoring the numerator, factoring the denominator. Now the numerator, there's a common factor of 2. So I'll pull 2 out, and we have times, 7t minus 6. And the denominator is already factored, t minus 6, t plus 6. And I am not seeing any common factors in the numerator and denominator. So this is it. All right, this is it right here. The value of this expression is the difference of these two that we started with. Now, of course, you can also multiply it out, right? This would be 14t minus 12 in the numerator. I'm just going to do this one more time here, divided by t squared minus 36 in the denominator. Totally valid, right? And the values of t that you can't replace t with, the values you can't use for t are 6 and negative 6. Right? Because if you replace t with 6 or negative 6, you'll be dividing by 0. You'll have denominators of 0. So again, check it out. Replace t with any number you want, as long as it's not 6 or negative 6, and see if this expression in the beginning is the same, has the same value as the expression at the end, and it should. All right, example 16. Pretty similar. This time I'll write it out a little more, right? The LCD would obviously be x plus 6 times x plus 3. Alright, so for this first fraction, alright, I'd be multiplying the denominator and the numerator by x plus 3. Alright, to get the LCD to be the denominator. And then we have minus, and then this second fraction, right, I would multiply the denominator and the numerator of this second fraction by x plus 6, right, the quantity x plus 6, to get the denominator to be the LCD. Alright, so again, I'll just keep them separate for right now. The first numerator would be x squared minus 9 divided by x plus 6 times x plus 3, right? I'm always keeping the denominator factored. Minus this second numerator would be x squared plus 6x over, and then again this LCD, x plus 6 times x plus 3. Alright, same two factors, doesn't matter what order you put them in. Now that they have the same denominator, right? They both have the denominator of the LCD. I can put them together. When you add or subtract fractions with the same denominator, right, that denominator is the denominator of the sum or difference. So we have x plus 6 times x plus 3, right, the LCD in the denominator. And then when you're subtracting, right, that's why I wanted to take this one a little more slowly. I think I did example 15 a little too quickly. You're doing the first numerator, x squared minus 9, minus the entire second numerator, right? You're not just subtracting the first term, but every term of the second numerator. So minus the quantity, x squared plus 6x. So we'll be distributing the negative. People tend to forget this with minus. People tend to forget this with subtraction. You're subtracting everything from the second numerator. So we have x squared minus x squared. That's nothing. Then no x minus 6x. So negative 6x. And then negative 9 minus nothing is negative 9. Right? Divided by, and then, x plus 6 times x plus 3. And then the final thing would be to factor out the common factor. Now again, the lead coefficient is negative, right, negative 6x, so I'm going to factor out a negative. The common factor here would be 3, so I'm going to pull out negative 3, and if I do that, you'll have 2x plus 3 left over. That makes negative 6x minus 9. And then divided by x plus 6 times x plus 3. And numerators factored completely, denominators factored completely, and I am not seeing any common factors. So this is the final result. You have negative 3 times the quantity 2x plus 3 divided by x plus 6 times x plus 3. The value of this expression should be exactly the same as the value of the original expression for any value of x, right, as long as x is not negative 6 or negative 3. Because if x were negative 6 or negative 3, you'd be dividing by 0 throughout this problem, and you can't divide by 0. Alright, and test it out. Replace x with any number you want, right, as long as it's not negative 6 or negative 3, and the value of the original expression should be the same as the value of this fraction here. Alright. You'll see that 17 and 18, again, very, very, very similar. Alright, example 17. Now I'm going to speed it up again, right? The LCD would be a plus 3 times a plus 6. The first numerator would be 5a times the quantity a plus 6. And then I'd be subtracting, the second numerator would be, and I'll put this in like brackets or something, it would be a plus 2 times a plus 3. right? That would be the second numerator when I get both denominators to be the LCD, right? And then again, both denominators are the LCD here, so that'll be the denominator of the difference, a plus 3 times a plus 6. All right, so what I have here, this would be the first numerator was 5a squared plus 30a. Right, then we're subtracting all of, right, that's why I had the brackets here. Maybe I'll keep it as brackets. You can put parentheses, doesn't matter. Subtracting all of the second numerator. The second numerator would be a squared plus 5a plus 6. And then we got again the LCD as the denominator, a plus 3 times a plus 6. Now, after distributing the negative, right, subtracting everything from that second numerator, we have 5a squared minus 1a squared. That'd be 4a squared. We have 30a minus 5a plus 25a, and then minus 6. Nothing minus 6, minus 6. Divided by a plus 3 times a minus 6, right, the LCD. Alright, so now I have it as a single fraction where the numerator is simplified. There's no like terms to combine anymore. Now we want to see if this can simplify any further. Now the numerator, right, this numerator can be factored. It would factor this way. You'd have 4a and a, and then we would need, oh, can it not be factored? Let me just think about this a little for a second. Alright, so actually no, sorry about that. This numerator cannot be factored any further. There's no common factor in all three terms, and it's a quadratic, so if you took the b squared minus 4ac, you end up with 721, which is not a perfect square, so this is it. This is it. Numerator is factored completely, and there's no 4a squared plus 25a minus 6 as a factor in the denominator, so there's no common factors. That's it. So the value of this difference is the same as the value of this expression, but as long as a is not negative 3 or negative 6. Right? Because if a were negative 3 or negative 6, you'd have denominators of 0. Okay, next, again, going to go pretty quickly now. I'm hoping it's obvious what the LCD is by now, right? This would be b minus 2 times b minus 8. All right, so that's going to be the denominator of the difference, b minus 2 times b minus 8. When I get that LCD to be the denominator of both, the first numerator would be 3b squared minus 24b, because I would have to multiply the first one by b minus 8 over b minus 8, right? And 3b times b minus 8 would be this, right? 3b squared minus 24b. Then we're subtracting then the entire second numerator. Now the second numerator, you would do b minus 6 times b minus 2, right? And b minus 6 times b minus 2 after foiling would be b squared minus 8b plus 12. Right, that'd be b minus 6 times b minus 2. And we're subtracting all of that, right? So distributing the negative here. So what I'm left with in the numerator is 2b squared, right? 3b squared minus 1b squared. Negative 24b minus negative 8b would be plus 8b. Negative 24b plus 8b would be minus 16b. And then minus 12. And we have divided by our LCD, b minus 2 times b minus 8. Alright, the numerator can factor. There's a common factor of 2. And if I pull that out, what we'd be left with would be b squared minus 8b minus 6, and b squared minus 8b minus 6 is not factorable. There are no factors of negative 6 that would add up to negative 8. So I'll leave it as that, b squared minus 8b minus 6, right? And this is not factorable any further. And the denominator is still totally factored, right? It's the LCD, b minus 2 times b minus 8. And I don't see any common factors in the numerator or the denominator, right? And the denominator, so that's it. That's as simple as that gets. Now you could also just multiply the numerator out, multiply the denominator out, and call it that too, but I'll leave it this way. All right. And the values that you can't replace b with are positive 2 and positive 8, right? Because those will give me denominators of 0. All right. And so I just mark that off to the side like I do every problem. All right. Same steps. All right. Same steps every single time. Example 19. All right, so this time, all right, the denominators need factoring. So 6 over, m plus 6 is already all factored, minus, and then 12m over m minus 6 times m plus 6. All right, so the LCD here would just be m minus 6 times m plus 6. Okay, so this denominator is already the LCD. I would just need to multiply the first fraction, right, the numerator and denominator, by m minus 6. And now that they both have the same denominator, right, that'll be the denominator of the difference, right, m minus 6 times m plus 6, the LCD there. And we're just combining the numerators. Right? 6m minus 12m would be negative 6m. And then we had the minus 36 here, minus nothing, right? So minus 36. So that's what you get when you combine the numerators. All right, and then this is great. The numerator's simplified, but I want to simplify the fraction. Now, as with other problems, right, you see the lead coefficient of the numerator is negative, so I will factor out a negative, and I'll pull out, negative 6 is common to both those. Or negative, 2 times 3 if you want. But I don't see a factor of 2 or 3 in the denominator, so I'm going to leave that as 6. And if I pull out negative 6 from the numerator, the other factor left over would be m plus 6. And we have m minus 6, m plus 6 in the denominator, and I'm seeing a common factor of m plus 6. Those will cancel. And so I'm left with, negative 6 divided by m minus 6. And there you go. That's as simple as that fraction's getting. And the values that I can't replace m with throughout this problem are 6 or negative 6, because that'll make that'll give me denominators of 0 throughout this problem, and I don't want that, right? You can't divide by 0, it's undefined. And check it out, test this out. Replace m with any number you want, as long as it's not these two, and the value of the original expression will be the same as the value of the final one, and I leave it to you to test that. All right, number 20, example 20 is very similar. Again, I'm going to factor the denominators. We have 4 over n plus 4 minus, and then 8n over, and then n squared minus 16 factors to n minus 4 times n plus 4. So hopefully you can see that that's the LCD. And it's this n minus 4 times n plus 4. So the second denominator is already the way I want it. So the first fraction, I would have to multiply the numerator and denominator by n minus 4. And then we subtract. Now the denominators are the same, right? So that's going to be the denominator of the difference, right, the LCD in the denominator, n minus 4, n plus 4. And then multiplying this, taking the first numerator and then subtracting the second numerator. We have 4n minus 8n, would be negative 4n, and then negative 16 minus 0 would be negative 16. And then I'd factor out a negative 4 from the top. We'd have n plus 4 left over. And then the common factor of n plus 4 would cancel, right, leaving me with negative 4 in the numerator and then n minus 4 in the denominator. There you go. That's as simple as that gets. No common factors. And throughout this problem, I could not replace n with 4 or negative 4, because that'll make me divide by 0 sometimes, and I can't have that. But for any other value of n, this is totally valid. Okay. 21. Same thing. Just subtraction. Alright, so one thing I'm noticing, personally, I like to have lead coefficients with with positive numbers in front of them, positive lead coefficients. So like 7 minus p is the same thing as negative 1 times p minus 7. Alright, and then you can pull the negative 1 out front and change this minus to a plus, right? And you've probably seen this before with subtracting opposites, right? What we're doing here is we're subtracting a negative, and that makes it a positive. So I can rewrite this as an addition problem, make it negative 9p minus 17 over, and I'll start factoring the denominators as well. P squared minus 4p minus 21, that would factor to p plus 7. I'm sorry, p minus 7. I don't know why I just didn't write plus 4 there. P minus 7 times p plus 3. Alright, p minus 7 times p plus 3. And then, like I said, this negative 1 here, I can pull out front. We have minus negative 1, making that plus. Alright, so it changes this subtraction problem to an addition problem. And then the second fraction is, p plus 1 over, and I pulled the minus 1 out, so now it's just p minus 7 in the denominator. Alright, so now my denominators are I pulled the negative 1 out, the denominators are factored. We can tell what the LCD is right away. The LCD would be p minus 7 to the first power times p plus 3 to the first power. Alright, so this first denominator is the LCD. So the only thing I need to do is change the second fraction. I would multiply the numerator and denominator of the second fraction by p plus 3. Right, so that way the denominators are the same. So now we have, negative 9p minus 17. There's the first numerator plus, right, remember I changed the minus to a plus with this negative 1. And then the second numerator, when you multiply it, would be p squared plus 4p plus 3. Right, that's p plus 1 times p plus 3. And then all of this divided by that common denominator, right, the LCD here, p minus 7 times p plus 3. Alright, now I combine like terms up in the numerator. Right, we'd have p squared. Then we have negative 9p plus 4p, that'd be minus 5p. We have negative 17 plus 3, negative 14. And then again the LCD in the denominator, p minus 7 times p plus 3. And great, there's the difference of these two. Right? But I do want to simplify it. Alright, try factoring the numerator. Well, the numerator does factor. That would factor to p minus 7 times p plus 2. And we have p minus 7 and p plus 3 as factors in the denominator. So I'm seeing the common factor of p minus 7 in the numerator and denominator. So I'm left with finally p plus 2 in the numerator, p plus 3 in the denominator. And that's as simple as that fraction gets. Now, of course, this is only going to be true, right? This first expression will only be equal to this last expression if p is not replaced with 7 or negative 3. Right, because if you replace p with 7 or negative 3, you're going to have a 0 in a denominator somewhere in this problem, and that's bad. You can't divide by 0. Example 22, same setup here. That one of these denominators, has a negative lead coefficient, a negative number in front of the highest powered term with the variable. So I'll pull out a negative. Again, this 4 minus q is negative 1 times q minus 4. Right. And just as with the previous problem, I could pull this negative 1 out front and make this minus negative 1, or turn the minus into a plus. So now this problem, let me separate the previous example. First fraction, I got negative 13q minus 8. And I'm going to factor the denominator of the first fraction as well. Q squared plus 2q minus 24. That would factor to q plus 6 times q minus 4. All right, and then, like I said, you got the minus negative 1 pulled out here. That's plus, right, minus the negative 1 plus. And then the second fraction, you got q plus 2 in the numerator. And when I pull the negative 1 out there, I'm left with q minus 4 in the denominator. So LCD, right, the LCD, looking at these factored denominators, would be q plus 6 times q minus 4. So the first denominator is okay. I would have to multiply the second fraction, right? I multiply the numerator and denominator by q plus 6. That's a q, sorry. Multiply the numerator and denominator by q plus 6. Alright, now I'm going to kind of say these things out loud here instead of write them. Alright, the denominator of both of these is LCD, so that's going to be the denominator of the sum, q plus 6 times q minus 4. And then we're just combining like terms with the numerators. Now this numerator would be q squared, and there's no q squared over here, so there's a q squared plus 8q, but then you have plus negative 13q, that would make minus 5q. Right, negative 13q plus 8q. And then you have a positive 12 here, and we got negative 8 plus 12, right? Negative 8 plus 12 would make positive 4. So here's a fraction, right? A single fraction. That's actually the the equivalent to the original expression. But we want to simplify even further if we can. The numerator, q squared minus 5q plus 4, that would factor to q minus 4 times q minus 1. Denominator is the LCD, right? Q plus 6 times q minus 4. Q minus 4 is a common factor in the numerator and denominator, leaving me with q minus 1 in the numerator, q plus 6 in the denominator, and that's as simple as that's going to get. No common factors. Alright, so this expression is going to have the same value as the original expression, right, for any value of q except negative 6 and positive 4. Right, so as long as q is not one of these values, these will be equal. Alright, and 23 and 24 are pretty similar to 21 and 22, where you have these, these polynomials I'm going to pull negative 1 out of in a denominator. So like here in example 23, again, 2 minus r, I'll think of as negative 1 times r minus 2, and then I can pull this negative 1 out front and make this into an addition problem. Have minus negative 1 making that into a plus. Okay, so just as before, first fraction, you have negative 2r minus 16 over, I'm going to factor the denominator, this would factor to r plus 8 times r minus 2. And then again, it becomes a plus. I'm doing minus the negative 1. So now the negative 1's gone, and the second fraction is 5 over r minus 2. Right. Again, hopefully it's clear that the LCD is simply r plus 8 times r minus 2. Right, so I don't have to do anything to this first fraction. It's already got the LCD as a denominator. And I multiply the numerator and denominator of the second fraction by r plus 8. Alright, so the LCD is going to be the denominator of the sum. Alright, r plus 8 times r minus 2 will be the denominator of the sum. And I'm just adding these two numerators, right? So we have negative 2r here plus 5r here. Right, we're going to distribute the 5 to the r plus 8. Negative 2r plus 5r would be 3r. Then you have negative 16 plus 40. Right, or 40 minus 16 would be plus 24. So the numerator is now 3r plus 24. Denominator is the LCD. I factor the numerator completely. Now the only thing you can do is factor out a 3. That'd be 3 times the quantity r plus 8 divided by the LCD, r plus 8 times r minus 2. Common factor of r plus 8 cancel in the numerator and denominator, leaving me with the final result, 3 in the numerator and r minus 2 in the denominator. So that's it. So this expression will have the same value as the original for any value of r, right, except 2 and negative 8. All right, if you replaced r with 2 or negative 8, you'd be dividing by 0 somewhere, and that's not good. All right, but for any other value of r, those two expressions will be equal. All right, very similar for example 24. See this, this denominator here with a negative lead coefficient. I don't like that. It's just a personal preference of mine. So because this has a negative lead coefficient, I'm once again going to factor out negative 1. So that way the coefficient on the t is positive, right? So 3 minus t becomes negative 1 times t minus 3. And then I can pull this factor of negative 1 out front, and that makes this minus negative 1 or plus again. I turn this into an addition problem. So the first fraction, you got 2t minus 30 divided by, and this denominator factors to t plus 9 times t minus 3. And as I said, we got the minus negative 1 that becomes plus, and then the second fraction is 2 over t minus 3. LCD hopefully is obvious now that the denominators are factored. It'd be t plus 9 times t minus 3. So I don't need to do anything to the first fraction. It's already got the LCD as a denominator. So I'm multiplying the second fraction. I'm multiplying the numerator and denominator by t plus 9. Right, so that way that both denominators are the same. And since both denominators are the same, I can put them together. I can add the fractions. And that common denominator will be the denominator of the sum, t plus 9 times t minus 3. And then I'm just combining the numerators, adding the numerators, right? So we'll multiply the 2 by the t plus 9 and add the numerators. 2t plus 2t would be 4t. Negative 30 plus 18 would be negative 12. All right, so 4t minus 12 is the numerator after combining like terms. They have a common factor of 4. All right, I'll pull the 4 out, and you'd have t minus 3 left over as the second factor in the numerator. And the denominator is again the LCD, t plus 9 times t minus 3. And I'm seeing a common factor in the numerator and denominator of t minus 3. We can cancel those, leaving me with 4 in the numerator, t plus 9 in the denominator. And there you go. That's the final result. That's as simplified as that's going to get. And this expression will have exactly the same value as the original, as long as t is not 3 or negative 9. Right, because if you replace t with 3 or t with negative 9, there's going to be a denominator of 0 somewhere, and you can't divide by 0. Right. All right, so moving along now, we're getting to different looking examples. All right, example 25. So notice that you have 2x plus 7 over 10x minus 1. You got a fraction plus 3. Now 3 is not technically a fraction, but you can think of it as a fraction if you want by just putting over 1. Right? Now it's a fraction. Right? 3 divided by 1. You can always do that when there's no denominator, right? Put it over 1. So very obviously now the LCD is just 10x minus 1. So the first fraction I'm not going to do anything to. It's the second fraction. Right? I'm going to multiply the numerator and denominator of this by 10x minus 1. So that way both denominators are 10x minus 1. And if both denominators are 10x minus 1, when I add them, that's going to be the denominator of the sum. And I'll be distributing the 3 to this 10x minus 1 here, and then we're going to add in the numerator. We're going to combine the numerators like terms. So I'll have 2x plus 30x, that'd be 32x, then 7 plus negative 3 would be positive 4. Okay, so I'm left with, I have 32x plus 4 in the numerator. Great, so there's a single fraction, wonderful, but then we try to simplify, right? Well, both the terms in the numerator have a common factor of 4. Pull 4 out. And if I pull 4 out, that would leave me with 8x plus 1 as another factor. And I've got, 10x minus 1 is the only factor in the denominator. So there aren't any common factors. So you could have left it like this or like this in factored form, same thing. But those are both as simple as that fraction is going to get. And again, you test it out for different values of x. Go back to the way the expression originally looked without the 10x minus 1s, right? Just with the plus 3. Replace x with anything, and you'll get the same value in the original expression as you do in the final one. I say replace x with anything, right? You can't replace x with 1/10, because if you replaced x with 1/10, the denominators would be 0. There'd be denominators of 0 in this problem, and that's not good, right? But anything else would be fine. Anything other than 1/10 would be fine. All right, very similar, but with a subtraction problem for example 26. Again, you see 6 here. That's the same thing as 6 over 1. Right? It has a denominator of 1. So very clearly, the LCD is just 5y plus 2. So the first fraction I don't do anything to. It's the second fraction that I'm going to multiply the denominator and the numerator by 5y plus 2. All right, the quantity 5y plus 2. And now the denominators are the same. So that's going to be the denominator of the difference. And what I'm going to do is I'm going to distribute the 6 here, and we're going to subtract. We're going to take the terms in the first numerator and subtract each term. All right, don't forget to distribute the negative as well. Subtract each term from the second numerator. So I have 8y minus 30y. 8y minus 30y. That'd be negative 22y. All right, 8 minus 30. 8y minus 30y. Negative 22y. Then in the first numerator, I have negative 4 minus 12, right? Minus the 6 times 2. Negative 4 minus 12 be negative 16. Okay, great. So wonderful. Now let's see if this simplifies any further, right? Now that I have a single fraction, let's see if we can factor the numerator and factor the denominator. Now the denominator is already factored, right? I'm just trying to see if the numerator has a common factor. Well, lead coefficient's negative in the numerator, so I'm going to pull out a negative, and the common factor of these two is 2, so I'm pulling out negative 2. And if I do that, what I'm left with is 11y plus 8. So my factors are negative 1, 2, and 11y plus 8 in the numerator, and the only factor in the denominator is 5y plus 2. And so I'm not seeing any common factors, so you can leave it like this, or you could, since there was no common factor, you could have also left it like that, right? Both of those are equivalent. All right, and so if you went back to the original statement without all the writing, the 8y minus 4 over 5y plus 2, then minus 6. If you went back to the original statement and replaced y with anything that's allowed, anything that doesn't make you divide by 0, you'll get the same exact value in this final statement too, right? Again, as long as y is not, let's see, negative 2/5, right? Because if y were negative 2/5, the denominators throughout this problem would be 0, and that's not good. But anything else would be fine. All right, the next examples, we're doing subtraction. And both denominators are quadratic polynomials. So as I've been doing, right, first thing is I want to find the LCD. Right, so I'm going to have to factor the denominators completely. So the first fraction is 3 over, then x squared minus 3x minus 4, right, that would factor to x minus 4 times x plus 1. I'll leave a little space, and we got minus, and then the second fraction would be 2 over, then x squared minus 5x plus 4, that factors to x minus 4 times x minus 1. Alright, so looking at these factored denominators here, right, the LCD would be x minus 4 to the first, there's x plus 1, and the highest power is to the first. And there's also an x minus 1 showing up in the highest powers to the first. So the LCD is x minus 4 times x plus 1 times x minus 1. Alright, so in the first fraction, I need to multiply the numerator and denominator by the factor x minus 1 to get it to be to get the denominator to be the LCD. Second fraction, I need to multiply the numerator and denominator by x plus 1, right, to get the denominator to be the LCD. Now the denominators have the same factors, right? The denominators are the same. So don't forget, with subtraction it's a little trickier. Right. We're going to take 3 times x minus 1, that's 3x minus 3, right? That's the first numerator. We're subtracting the entire second numerator, which would be 2x plus 2. Multiply those, 2 and x plus 1. Be 2x plus 2. But don't forget, we are subtracting everything, subtracting every single term of that second numerator. So that'll involve, distributing the minus, right, distributing the negative. And this, common denominator is the LCD, x minus 4 times x plus 1 times x minus 1. Alright, then I combine like terms, simplify the numerator a bit. 3x minus 2x would be x. Negative 3 minus 2 would be negative 5. Alright, so the numerator is x minus 5, and the denominator is, the LCD, x minus 4 times x plus 1 times x minus 1. And, the numerator is totally factored already. Denominator is factored. There are no common factors, right? I'm not seeing any x minus 5s in the denominator, so this is it. This is as simple as that fraction gets. Now again, you can leave it in factored form like this, or actually multiply out what the denominator will be and write it that way if you want. But I'll leave it like this, where everything's factored. And then off to the side, the values I can't replace x with, right? Because I don't want to have denominators of 0, are 4, 1, and negative 1. 4, 1, and negative 1. So you can replace x with any number you want, except these three, because these three will give me denominators of 0, will make me divide by 0, and that's undefined. That's not good. All right, so very similar for next example. I'm going to factor the denominators first, find the LCD, the least common denominator. First denominator, would factor to x minus 5 times x minus 1. Then we have minus, and then second fraction, 3 over. That denominator would factor to x minus 5 times x minus 2. So the LCD would be x minus 5 times x minus 1 times x minus 2. So I found the LCD. Now I want to make it so that both fractions have that denominator. So the first fraction, I'd have to multiply the numerator and denominator by x minus 2. The quantity x minus 2, don't forget parentheses. Second fraction, I'd have to multiply the numerator and denominator by x minus 1. Again, the quantity x minus 1, the factor x minus 1, so don't forget parentheses. So I'm just going to write out what the simplified version is at the end, right? So again, I'm distributing the 4 here, distributing the 3 here, but don't forget we're subtracting everything. You're subtracting all of this. So it's like distributing the negative as well, almost like you're distributing negative 3 instead of positive 3. So in the first numerator, I'd have 4x minus, in the second numerator, I have 3x. 4x minus 3x would be 1x. In the first numerator, I'd have negative 8 minus, in the second numerator, I'd have negative 3. Negative 8 minus negative 3 would be negative 8 plus 3. Negative 8 plus 3 is minus 5. So I have x minus, after taking the terms of the first numerator and subtracting all the terms of the second numerator, I end up with x minus 5. Then the denominator is the LCD, x minus 5 times x minus 1 times x minus 2. Numerator is totally factored, denominator is totally factored, but here this time I am seeing a common factor. There's a factor of x minus 5 in the numerator, factor of x minus 5 in the denominator. Now don't forget, when you divide things out, when you cancel common factors, they technically become the number 1. So what I'm left with in the numerator is the number 1. And what I'm left with in the denominator are the factors of x minus 1 times x minus 2. Right. And if you want to multiply that out, make it x squared minus 3x plus 2, that's fine, but this is totally fine right here, right? Keeping things factored. So 1 divided by x minus 1 times x minus 2 is the final simplified fraction. So the value of this expression will be exactly the same as the value of the original for any value of x except 5 and 1. Right? X can't be 5, x can't be 1, because if x were 5 or 1, you'd be dividing by 0. Or 2. I forgot 2. X can't be 2 either, because there'd be a 0 in this denominator. Right? Whatever numbers make any denominator 0 are not allowed. Right? Wonderful. All right. Next two examples, very similar to these two. All right. Examples 29 and 30. Well, example 29, again, starting off the same way. First fraction, 5 over. This denominator would factor to x plus 9 times x minus 1. Then we have minus the second fraction, 4 over. This would factor to x plus 9 times x plus 1. So the LCD, right, would be x plus 9 times x minus 1 times x plus 1. All right, so I'm trying to make both denominators look like that. So for the first fraction, I'd have to multiply the numerator and denominator by the quantity x plus 1. For the second fraction, I'd have to multiply the numerator and denominator by the quantity x minus 1. All right, and don't forget, we're subtracting all of that second numerator. So I'll distribute the 5 here, distribute the 4 here, and then subtract both terms, right? Subtract every term. So in the first numerator, we have 5x minus 4x, making 1x. And then first numerator has 5, second numerator has negative 4, but we're subtracting. 5 minus negative 4 would be 5 plus 4, which would be plus 9. So the numerator, after combining both numerators, we have x plus 9. And that common denominator is the denominator of the sum, or the difference, right? That LCD, x plus 9 times x plus 1 times x minus 1. And there is a common factor. X plus 9 is common to both the numerator and denominator. And don't forget, when you cancel common factors, they become the number 1. So the numerator is the number 1. The denominator has these two factors left over, x plus 1 times x minus 1. Or if you want, you could write that out as x squared minus 1. Right? Either one of these is fine. You can leave it in factored form, or you can multiply things out. Great. And the values of x that can't be used throughout this problem are negative 9, positive 1, and negative 1. All right, these are the values that would make denominators 0 throughout this problem, and you can't have denominators of 0. But for any other value of x, the original expression will be equal to the final expression. And you can test that out if you want. Plug in different values of x. Okay, same kind of problem. Example 30. First fraction, right? 3 over, and I'm factoring this denominator here. That would factor to 2x. 2x plus 1 times x plus 2. Right, just FOIL and double check that. Yes. Minus, and then the second fraction, 1 over, again I'm factoring this denominator, that'd be 2x plus 1 times x plus 1. And again, double check it, FOIL, and yeah, that's 2x squared plus 3x plus 1. Alright, so looking at the factor denominators here, the LCD would be 2x plus 1 times x plus 2 times x plus 1. Alright, there's the LCD. And I'm going to try to change both fractions so they have that denominator. So the first fraction, I'd have to multiply the numerator and denominator by the quantity x plus 1. And the second fraction, I'd have to multiply the numerator and denominator by the quantity x plus 2, so that the denominators are now both the LCD. They have the same factors as the LCD. Alright, so don't forget, you're subtracting everything from this numerator here. Alright, you're minusing the x, minusing the 2. And we're distributing 3 here. Alright, so the first numerator has 3x minus the second numerator has 1x. 3x minus 1x is 2x. First numerator has 3 minus the second numerator has 2. 3 minus 2 is positive 1. So I have 2x plus 1 left over in the numerator. And the denominator, right, is that common denominator when you add or subtract, right? The common denominator stays throughout. And it's the LCD, 2x plus 1 times x plus 2 times x plus 1. And I am seeing a common factor in the numerator and denominator, right? It's this factor of 2x plus 1. When those cancel, I'm left with 1 in the numerator, right? Because there's nothing left over, just the factor. When factors cancel, they become 1. And the only factors I'm left with in the denominator are x plus 2 times x plus 1. And there you go. That's as simple as that gets. And if you'd like, you could multiply things out, make the denominator x squared plus 3x plus 2 if you want. And then off to the side, as I've been doing with every single example, the values I can't replace x with throughout this problem are -1/2, -2, and -1. Right? X cannot be any of these three numbers, because those will make me divide by 0. Those will make denominators 0 throughout this problem. But any other value is fine. Replace x with anything else, and the value of the original expression will be exactly the same as the value of the final expression. All right. So far in examples 1 through 30, we've been given two fractions to add or subtract. All right. In the final 6 examples, we are given 3 fractions. Nothing changes. Nothing changes at all. It's just now you have another numerator to combine, right? So you do the same stuff, right? You get a common denominator. First, I'm going to factor all the denominators, right? So first fraction is 5a over a minus 2 still, plus second fraction is 9 over a, then minus, and then the last fraction you have 2a plus 18 over, and then this denominator factors to a times a minus 2. And if you look at all three denominators, the LCD is same thing. Just list any factors that show up. You got a to whatever the highest power of that factor is. The highest power of a in any of these three denominators here is a to the first. So a to the first will be in the LCD. Then I'm seeing a minus 2 show up, right? A minus 2 will be a factor, and then the highest power on a minus 2 in any of these is a minus 2 to the first. So a minus 2 to the first will be in the LCD. And those are the only factors that show up, a and a minus 2. So there's your LCD, a times a minus 2. And then I'm going to rewrite all three fractions with the LCD as a denominator. All right, so the first fraction, I would have to multiply the numerator and denominator by a. The second fraction, I would have to multiply the numerator and denominator by the quantity a minus 2. And the third fraction I don't need to do anything to, because the denominator already is the LCD, has the same factors. So now I'm rewriting each fraction. Now the first fraction would be 5a squared divided by the LCD, right? A times a minus 2, plus second fraction, 9 times a minus 2 would be 9a minus 18, right? Distributing the 9, divided by the LCD, a times a minus 2. Then minus third fraction, the numerator is 2a plus 18. Denominator is the LCD, a times a minus 2. Now every single fraction has the same denominator. Right? Now you could do it 2 at a time if you want. Right? You could do it 2 at a time. Remember when you're doing order of operations, when you're adding and subtracting, just do it left to right. You can do it 2 at a time, or just say, hey, you know what? I'm adding and subtracting here, and when you're adding and subtracting fractions with the same denominator, that denominator will stay the denominator of the final sum. So the final denominator is going to be a times a minus 2 here, and then you're just combining like terms. So you're taking 5a squared, you're taking the first numerator. I'm going to put these things in parentheses, right? The first numerator plus the second numerator, 9a minus 18, minus, and then the third numerator. Again, I'm putting all these in parentheses right now just so you know that you're adding every term of the second numerator, and then you're subtracting every term of the third numerator. So that's going to involve distributing a negative, right? Be careful with subtraction, right? You've seen subtraction earlier in the video. Now combining all these like terms, I have 5a squared There's no a squared here, no a squared there. So I have 5a squared. Then there's no a here. There's a 9a, right, plus 9a minus 2a. Plus 9a minus 2a would be plus 7a. And then there's no constant in the first numerator. Plus negative 18 in the second numerator, that'd be negative 18. Minus positive 18 in the third numerator. So 0 plus negative 18 would be negative 18. Minus 18 would be negative 36. All right, negative 36. All right, so the numerator ends up being that when simplified, 5a squared plus 7a minus 36. And then the denominator is, the LCD, a times a minus 2. And I'm going to keep it factored. Now let's see if we can factor the numerator. Now it's a quadratic, so I'm going to do the whole b squared minus 4ac test. Take 7 squared, right, the middle coefficient squared, minus 4 times the lead coefficient times the constant, negative 36. Getting 769, and see if that's a perfect square. Take the square root of that 769. It is not. That's not a whole number. So the b squared minus 4ac test tells me, because b squared minus 4ac is not a perfect square, this is not factorable. And there's no common factor to pull out either. So this is as simple as that fraction gets. So that is the result of adding these two fractions and then subtracting this one. Let me get this one here. So, and go ahead and replace a with any number you want, except 0 or 2. Right? Because if a were 0 or 2, you'd be dividing by 0 somewhere, and that's not good. But replace a with any other number, right? Any number besides 0 or 2, and the value of the original sum and difference, the value of the original expression will be the same as the value of the final expression, and that should always happen. And I leave it to you to test different values of a if you wish. All right. Next example, and again, the remaining examples in the video are all very similar. Right. Where I'm adding and subtracting with 3 fractions, but I'm doing the same stuff, right? Make sure you get a common denominator, least common denominator. So first I factor all the denominators. So we have 2b over b minus 5, that's already factored, plus 3 over 2 times b, that's already factored. 2 times b is totally factored completely. Minus, and then 2b minus 15 over, and then this denominator factors. You can pull a 2b out of these two terms, 2 times b, and what would be left over would be b minus 5. Alright, so looking at the denominators, right, the LCD would be 2 to the first times b to the first times b minus 5 to the first, right? And again, I've already talked about in previous videos and earlier, very early on in this video, how to find the LCD. So great. Now I'm going to try to make every single one of these fractions an equivalent fraction with this denominator. So in the first fraction, right, I'd have to multiply the numerator and denominator by 2b. All right. The second fraction, I'd have to multiply the numerator and denominator by the quantity b minus 5. Now the denominator is the LCD. And for the third fraction, right, the denominator is already the LCD. Alright, so I'm going to do this. Remember that when you subtract, you're subtracting every single term. So I'm subtracting 2b and subtracting negative 15. Alright, so it's like distributing the negative. And I'm just going to combine like terms in the numerator right now. Alright, so all 3 fractions have the same denominator. That's 2b times b minus 5. Alright, so I'm going to write that. That's going to be the denominator of the sum. And we have in the first numerator, we have 4b squared. And there's no other b squared there, no b squared there, so we have 4b squared in the first, when we put all the b squareds together. Alright, then there's 0b, no b to the first in the first numerator. There'd be 3b in the second numerator, and 2b in the third. We got 3b minus 2b, making positive 1b. Alright, then for the constants, there's no constant in the first numerator, so I'm not worried about that. Then we have negative 15 minus negative 15. Negative 15 minus negative 15, that'd be negative 15 plus 15, that's 0. So all I'm left with in the numerator, when I'm done combining like terms, is 4b squared plus b. Alright, the constant would be 0. Okay, well now, this is great. This is the sum and difference of all these fractions, but let's see if we could simplify. The numerator does factor further, right? There's a common factor of b. And if I pull a b out, then what's left over would be 4b plus 1. So there's the numerator totally factored, and the denominator is, 2 times b minus 5, and I am seeing a common factor, b. There's a b in the numerator, a b in the denominator as a factor, right? That's part of a product. And there we go. That's it. So the final result is, I have 4b plus 1 left over in the numerator, and I have 2 times the quantity b minus 5 in the denominator. Now you can leave it that way or actually multiply it out, right? 4b plus 1 in the numerator and 2b minus 10 in the denominator. Both are equally valid, right? They're both the same expression. Alright, and the values that I can't replace b with would be 0 or 5, right? I can't replace b with 0, and I can't replace b with 5 because that would make denominators equal 0, and you can't have denominators of 0. Right? That's dividing by 0. That is an undefined operation. Okay, so 33. Very, very similar. Alright, so what I'm going to do is kind of speed this up a bit. These denominators are already factored. C squared minus 4, that'd be C minus 2 times C plus 2, which you may notice are the same as these two factors here. So the LCD is just this last denominator, C minus 2 times C plus 2. So I'd be multiplying the first fraction, I'd be multiplying the numerator and denominator of the first fraction by the quantity C minus 2. The second fraction, I'd be multiplying the numerator and denominator by the quantity C plus 2. Right, and I wouldn't do anything to the last fraction because it already has the LCD as the denominator. Alright, so that LCD is going to be the denominator at the end, right, when I combine them, when I add and subtract everything. Now that all the denominators are the same, that's going to be the denominator of the final result. And then let's go through and combine some like terms. So I have c squared, minus 2c plus 5c plus 10, and then minus 10c. Alright, so you got c squared, and there's no other c squareds. Then we have minus 2c plus 5c, that'd be 3c, minus 10c would be minus 7c after combining all the c to the first power terms. And then the constants, well, there's only one constant, that'd be plus 10 in the middle here. Right, there's no other constant terms after multiplying things out. So plus 10. Great, so I got a single fraction, the numerator is simplified. Let's see if we can simplify the fraction as a whole though. Right, factor the numerator, factor the denominator. Well, this one can be, right? The numerator factors to c minus 5 times c minus 2. And the denominator was that LCD, right? C minus 2 times C plus 2. and I am seeing, hooray, right, a common factor of c minus 2 in both the numerator and denominator. So I'm left with c minus 5 in the numerator, c plus 2 in the denominator, and that is it. There are no more common factors. Alright, so the value of this expression will be exactly the same as the value of the original, right? Get rid of all the writing I did and look back at the original, and plug in any value of c you wish except for 2 and negative 2, right? C can't be 2 or negative 2, because that'll make denominators 0. But anything else, right? Any other value of c will make this expression equal to the original, and you can go ahead and test that out with different values of c if you want. Alright, so 34, very similar. Again, I'm going to kind of speed things up by just saying, hey, this denominator is factored, this denominator is factored. If I were to factor this denominator, right, d squared minus d minus 20, that's just d minus 5 times d plus 4, right, which is just the product of these other two. So that's the LCD. I mean, the LCD here, again, hope it's obvious that the LCD is d minus 5 to the first times d plus 4 to the first. Alright, so I don't need to do anything to the third fraction, just the first two. Now the first fraction, I would multiply the numerator and denominator by the quantity d plus 4. Second fraction, I would multiply the numerator and denominator by the quantity d minus 5. And now we have a common denominator, right? The LCD is the denominator throughout this. And we're doing a bunch of addition and subtraction. When you add and subtract and all the denominators are the same, right, that's going to be the denominator of the sum. So d minus 5 times d plus 4 will be the denominator of the sum. And I just combine like terms in the numerator. Alright, so the first numerator has 6d squared plus 24d. The second numerator has just d minus 5, right? And don't forget, you're subtracting that third numerator. You're subtracting both terms, so it's like distributing the minus 1. You're subtracting the 7d, you're also subtracting the negative 5, or adding 5, right? Minus negative 5 is plus 5. Alright, so I have 6d squared, and there's no other d squared, so 6d squared. You got plus 24d plus 1d, that's 25d, minus 7d would be plus 18d. Alright, 24d, 25d, minus 7d, 7d would be 18d. Alright, then there's no constant term in the first numerator. There's negative 5 in the second numerator, minus negative 5 in the third numerator. Negative 5 minus negative 5 would be negative 5 plus 5, or 0. So that's it. There's no constant terms left. So I'm left with 6d squared plus 18d. Now, you can factor that further, right? They have a common factor of 6d. And if I pull out 6d, I'm left with d plus 3. Right? Divided by, and then the LCD was d minus 5 times d plus 4. Right, those quantities. And looking at the factored form, I'm not seeing any common factors in the numerator or the denominator. Right, so this is as simple as this gets. And you could have also circled the other one too, because nothing canceled. Right. And the values of d I couldn't use would be 5 and negative 4. Right. Because if you use 5 for d, negative 4 for d, you're going to be dividing by 0, or you're going to have denominators of 0 throughout this, and that's not good. All right, and check, plug in any other value for d you want, and go back to the original expression without all the writing I did. Go back to the original expression, plug in those values of d, and see, is it equal to the final expression I had. Okay, wonderful. All right, now we're coming to the last page. All right, examples 35 and 36. Again, very, very similar to the previous ones where you're fraction plus fraction minus another fraction, right? And again, just pay attention to where there's addition and subtraction in whatever examples you're working on. Okay, so I'm not even going to factor stuff. I'm hoping you're seeing that LCD here is d times d plus 2. Alright, that's this last one here, and that's d, and that's d plus 2. So I don't need to change the last fraction. The first fraction I would multiply by d in the numerator and denominator. Next one, I would multiply the numerator and denominator by the quantity d plus 2. And now all the denominators are the same. Right? All the denominators are d times d plus 2. Alright, now don't forget you're subtracting each term, right? So like the minus 1 is going to both of these. You're subtracting d and subtracting 8 from the last numerator. Here you have 4d plus 8. Here you have 3d squared. So we have 3d squared plus 4d minus 1d, that'd be plus 3d, and then plus 8 minus 8, so there's no constants. Alright, so the numerator, after combining all the like terms, would simplify to just 3d squared plus 3d. You could factor out a 3d from the numerator, and that would leave you with d plus 1 divided by, and then d times d plus 2, and I am seeing a common factor this time. Right? The common factor is d. So I'm left with 3 times the quantity d plus 1 in the numerator, and the factor, and if it's the only factor, there's no need to have parentheses around it, d plus 2 in the denominator. And there you go. That's as simple as it gets. Or you could, multiply it out, make it 3d plus 3 in the numerator, but whatever. Alright, that's as simple as that fraction gets, and the only values of d I couldn't have used were 0 or negative 2. Because if you replace d with 0 or negative 2, you'll have a denominator of 0 somewhere. Alright, and you can check other values if you wish. Go back to the original expression before I did all the writing. Plug in a value of d that's not 0 or negative 2 and see if the original expression has the same value as the final one, and it should, if you did everything right. Alright, and same thing here. This last denominator is just the product of these first two, right? Q plus 5 times Q minus 3. So that's the LCD. Right? The LCD is Q minus 5, or Q plus 5 times Q minus 3, right? Which is the last denominator, so I don't need to do anything to that one. First fraction, I would multiply the numerator and denominator by the quantity Q minus 3. Second fraction, I would multiply the numerator and denominator by the quantity q plus 5. And the third fraction I wouldn't do anything to because that already is the denominator, right? So the LCD, now I have the LCD as the denominator everywhere. So that's going to be the denominator of the final sum, right? Q plus 5 times q minus 3. So I got the LCD in the denominator. Now I'm just combining all the like terms in the numerator. And don't forget, when you subtract, you are subtracting every term from that numerator. So I have 2q squared. There's no other q squareds. Right? So 2q squared. We'd have minus 6q plus 3q. Minus 6q plus 3q would be minus 3q minus 13q. So again, one more time. Minus 6q plus 3q would be minus 3q. Minus 13q would be minus 16q. And then constants. There are no constants here. There would be plus 15, minus 15, so that's it. That's 0. Right. Okay, and then looking at this numerator, we can factor out a 2q. And if I do that, we're left with q minus 8. And the denominator has factors q plus 5 and q minus 3. And looking at the factored numerator, factored denominator, there are no common factors in the numerator or the denominator there, and yeah, that would be it then. I'll circle that. Now you could, if you wanted, multiply things out and write out the multiplied out numerator, multiplied out denominator, and that's fine too. All right, and the value of q could not be replaced by -5 or +3. All right, because if you replace q with -5 or +3, you'll be dividing by 0, and you cannot divide by 0. You'll have denominators of 0, and that's bad. But test out any other value, right? Replace q with anything besides these two, and the value of the original expression before I did all the writing, the value of the original expression should be exactly the same as the value of this final expression here. Okay, almost a 3-hour video, but again, you can skip around. I'm not expecting anyone to watch all 3 hours. All right, just you got the time stamps for examples in the description of the video. You can bounce around and look at specific ones you want to look at that correspond to different exercises in that section 7.2 of the OpenStax.org book there that I described at the beginning of the video. All right, and hopefully watching me go through these 36 examples, if you have watched them all, help you out when you're working on similar problems. And thank you very much for watching.